Let's do it.
I'm totally not ready for this final.
Yeah. Okay.
All right, you ready? Okay.
You ready?
Yeah, I can read it. Okay, which of the following variables is R quantitative? Mark all that apply. The number of people in randomly selected classrooms on campus, the 3 most common brands of car found in the U.S., the telephone numbers of randomly selected business in town. AB one. I know C would, because it's numbers. Right?
1, 2. Yeah.
Would A be one? Because I think, yeah, the number of people.
Yeah.
Okay.
Is the telephone number still? Yeah, because it's. I mean, I'm just thinking. It's numbers, but.
And I guess.
Yeah. You know what I'm trying to say? Yeah, see, in the text it says categorical variables and do not make sense to do arithmetic with them. The following are examples of categorical: gender, nationality, phone number, etc. So I don't think it's C.
Okay, phone number would be categorical. Okay, so A, just A?
Yeah, I guess.
Okay.
Students in an introductory statistics class in BYU, Idaho are studying prices of cold cereal at grocery stores in Rexburg. To get a sample of cold cereal prices, they went to Albertsons and rolled a die to decide which box from the left top shelf they would start on. Then they recorded every 6 cereal after the first, moving from left to right down the shelves, according to name, size, price of each cereal of their sample. Is their study an experiment or an observational study, and why? I would say experiment because they have control over the sample. I guess I'll look at them. In a design experiment, researchers manipulate the conditions that participants experience. Yeah. In an experiment, researchers control the conditions under which the measurements are made. In an observational study, researchers simply observe what happens without controlling the conditions.
So it's definitely an experiment. It's just whether there's no control, which I think because they had control over the sampling method because they did it every 6 cereal after that. So they're the one who chose the method to sample. Okay. In worst case scenario on this one, we have 2 tries. So
True.
After we do it once, look at all the right answers and go back and do it again.
Oh, we have 2 tries?
Yeah, this one we have 2 tries.
Cool.
Yeah.
I might do that. So, I mean, just in case we do bad.
Yeah. It's definitely worth going back if we don't do very good.
Yeah. My grades.
Okay. For a Math 221 project, one group of students studied the ages of students on BYU Idaho campus. They collected data from a random sample of n equals 100 students. The sample mean was 21.2, and the sample standard deviation was 2.61. An excerpt from the data is given below. The group notices an error in the data. The age of one of the males ID3 ID equals 3 was entered incorrectly. He is actually 21 years old. When the error is corrected, what will happen to the sample mean? Or sample mean? Mean will increase, mean will decrease, mean will stay the same. It's not possible to determine this without a full set of data. I would say that one because you don't really know where the middle is, right?
What?
I'd say D because you don't know where the middle is, so you don't know where 12 really fits in that, right? Or would you go?
Well, I think he was able to figure out in theory. Hold on, I remember this exact question in our homework. But I can find it. I'm actually thinking that the median would decrease because it would be an outlier. I can't find it.
I was just thinking, just because we don't know we don't see all the numbers, so we don't know if the median is below 21 right now. So if that was switched to 21 or not, you can't really tell if it's, I don't know.
Well, if they're all students at BYU campus, they're all going to be in between, like, 17.
Yeah.
You know what I mean? Loads.
That's true.
But I remember this exact question. Okay. Whatever.
So you think it's decrease?
Yeah. But we can agree or disagree if you want. I don't care. Remember which lesson we talked about errors?
I don't. Was it 10? Yeah, number 10 is when we talk about lesson 10, margin of errors.
Oh. I can't find it.
I guess we can just put 1 and hope it's right. We'll see if we have to go back later.
Yeah, that's true. Okay. Do you want to move on then?
What was that?
Equals moving on then.
Yeah.
Time to complete a standardized exam for BYU test center is approximately normal, with a mean of 70 minutes and a standard deviation of 10 minutes. Using the 16 whatever rule, approximately what percentage of students will complete the exam under 50 minutes? Give your answer according to 1 decimal place.
I think it's 95.
Yeah. Well, hold on. Sorry, I have to like visualize it. To be. Yeah, I think so too. Wait. Under 50 minutes. So it would be half of 5. So I think it would be 2.5%. It said under 50 minutes. And between 50 and 90 is going to be 90%, and so half of 5% would be below.
Oh, yeah, you're right. You're right. I was like, what are you talking?
Does that make sense?
Yeah. So what is it? What did you say you had?
I think it's 2.5.
Okay. The score on the LSAT are approximately normal with means 150.7 and standard deviation of 10.2. Queenie School of Business in Kingston, Ontario requires a minimum LSAT score of 157 for admissions. Find the 35th percentile of the LSAT score. Give your answer accurate to 1 decimal place. Use the applet. And this was one I didn't know how to do. I was looking at it, I don't remember how to find percentiles.
Yeah, I'm going to have to find that.
I was really hoping this would just be the last chapter.
Yeah, me too. I totally thought it was going to be. But I guess not.
Okay. So this stuff's in lesson 5.
Oh, okay.
Okay, so I think we just put the percentage in the applet, so 0.35. No, that's not right.
Yeah, I think you're right. Maybe at the top, and then find the z-score, and then use the z-score to find. Did they give us the standard deviation? Oh yeah, yeah. So we just find. So
So which do we shade? Which side do we shade?
In the text it says to shade the middle and the bottom, but then when I put it in there, it automatically shaded just the bottom half.
Just the bottom half?
Yeah.
Okay. So did you get 0.1749? Wait. Whoops. Sorry, I changed it. Negative 0.385?
Yeah.
Okay.
I'm not sure if we should do negative or not. I think we would just do the positive one.
Okay.
And then so it'd be 0.385 equals x minus 150.7 divided by 10.2. And then we just solve for x. Is that what you're thinking too?
Too many screens open. I keep trying to click back and forth.
Yeah. No, I have two screens. It's really, I can't imagine doing anything without. It's spoiled.
Yeah, that'd be way nice.
You know what? I think it is negative. Just kidding. I'm sorry. Because I got the answer 154.627, and that's higher than the mean. So I can get that.
Yeah.
I think it's negative. Sorry. What is it?
I'll be right back. I'm gonna grab my calculator. It's in my living room.
Okay.
Did you get 146.773?
Yep. Not sure. It sounds right to me.
Okay. Sounds good.
It's my turn, right?
Yeah.
Team of Dermot Tower removal researchers were studying skin cancer among 60 and 70-year-old American men. Suppose you are part of the research team and take a sample of n equals 70 men from this age group and calculate the mean number of skin cancer spots in the sample. Also suppose that it is known that the distribution of the number of cancer spots is right skewed. Suppose the sample size for the study is n equals 2. What would be the shape of the sample?
Right skewed still, right?
Yeah.
Because there's not high enough to make it normal.
I would think that then that's like the tiniest sample size ever.
Yeah.
Like, is it even like, is it even, I can't talk right now. Yeah, let's just do that.
I think it's right skewed.
Yeah, I mean, it makes sense that it would follow the same pattern. I just wonder if the sample size of 2 doesn't even count because it's so small. You know what I mean?
Yeah. Could be a trick question. Who knows? All right. Tanker trucks are designed to carry huge quantities of gasoline from refineries to filling stations. A factory that manufactures the tank of the trucks claims to manufacture tanks with a capacity of 8,550 gallons of gasoline. The actual capacity of the tanks, as normally distributed, would mean U equals 8,544 gallons and standard deviation of it equals 12 gallons. Use the information to answer questions 8 and 9. All right. A simple random sample of n equals 20 tanks will be selected. Find the z-score corresponding to the sample mean capacity for 20 tanks of 8,544. Round your answer to 3 decimal places.
Okay. Eight 8,554 minus 8,550. Just a simple z-score.
Yeah, I think it's just
Divided by 20. Oh no. Standard deviation.
be 20 minus 8,544 divided by 12. I think that's it, right?
Well, 20.
Wait, that's, I guess, never mind. Or I think 8,550 minus, right? I don't know.
Sorry. Did it give us the standard deviation? Oh, yeah, 20, 12. Yeah, sorry. I forgot it gave us the percent here. Did you get negative 0.5?
No. So what equations did you enter in?
I
I don't remember how to do this stuff.
just the normal z equals x minus mu divided by the standard deviation. But do we have to do the whole dividing that by the square root of 12, 20 or something?
That's what I can't remember. Because I can't remember what to do when you have a...
Oh, yeah, it says find z is more corresponding to the sample mean. So yeah, I would probably have to do it. Which one is that in? Sigma Nova? Yeah, that's what we do. It's so that you divide by 12 divided by the square root of 20.
Okay. So did you get 0.236? What did I do wrong?
I got negative 2.226.
So do you do...
So
So do you do 8,550 minus 8,544?
did the 44 first because it's x, and then we subtracted by mu. Because mu is, oh, you're right.
Okay.
Oh, you're right, yeah. Sorry, I didn't check that.
It wouldn't surprise me. Me and you always get like the same numbers, but negative or positive.
Yeah.
I feel like half our assignments, it's been like, well, I got that number, but...
Oh, so mu is the second one. So you got 2.235 or 2.6?
2.236.
Yeah, so not negative. Okay.
Yep.
Sorry. Gotcha. We're good.
Okay. Perfect.
I get F's on our, so we like double check each other.
Yeah.
Okay. Did I read that one? I can't remember.
No, I read that one.
A simple random sample of n equals 50 tanks will be selected. What is the probability that the mean capacity for these 50 tanks will be greater than that? Round your answer to the digits. Probability. So we just do the same thing with the disease, find the disease score and put it in the applet.
Yeah. The applet.
But different numbers, right?
Yeah.
So
is 8,540, is that mu?
that's x, because x is the sample size. Mu is the population.
Okay. Sweet. See, that's my biggest thing, just remembering which numbers are what.
Yeah. Okay, I've got negative 2.357. Is that? Let me know if that's what you got.
So negative 2.357?
Yeah.
Yeah.
Okay, cool. And then what is this greater than that? So the middle.
To the right.
I got 99.08. That's me.
I'm still trying to get back to the applet.
Oh, sorry.
I got 0.9908.
Yeah.
So 0.991 then.
Does that seem too high?
I don't know what else we would do. That seems the only.
Okay.
I feel like we did it, right?
Yeah, me too. Okay.
Okay. Which of the following best describes the notion of the significance level hypothesis test? The probability of an error, type 1 error, the probability of type 2 error, the probability of rejecting H null, whether it's true or not, the probability of statistic at least as extreme as the one you calculated, assuming the null hypothesis is true.
It's type 1 error.
That's what I was thinking.
In other words, the level of significance is the probability of committing a type 1 error. Right?
What was that?
Is that what you're thinking too?
Yeah, I was thinking type 1 error.
Okay, cool. The heights of young adult females in the U.S. are said to have a population standard deviation of 2.6 inches. The example was taken of an 85 young women females, a mean of 65.4. Which of the following explanations describes the correct way to interpret 95% confidence interval for this problem? I've been meaning to keep looking this up because I keep asking this question and I'm not sure.
I just always look for the true mean because I know it talks about having the true mean.
I'm 95% confident that the true mean. Yes. True mean, so the B or not.
I think it's just B. I don't know. I think it's B. Because it always talks about having the true mean of it in R, like saying that we're confident, and that's the only one that says the true mean plus confidence in it.
Well, do you think that's the only one?
Yeah. But I could be wrong. But that's the one that I would choose.
I think you're right. This whole time I thought that there was like. Hold on. Oh, hey, I just found the same question. It says that the approximately 95% of all 95 confidence intervals could be computed in the population. It's the same exact question. Here, let me show you. It's being broken down crazy. See? The same question. This is true.
Okay. That is the same exact question, so we're going to go with that.
Okay. That's what I was trying to find for that other one, because I swear we've had that question before.
Yeah. We've just covered so much stuff in this class, it's ridiculous.
I know. I think I have to use it again for a class I'm taking next semester, which I'm not excited about.
Yeah, this is the only statistics-related stuff that I have to take, so I'm very grateful.
That's awesome.
Yeah. All right. Marine biologists have been studying the effects of acidification of the oceans on weights of male beluga whales in the Arctic Ocean. One of the studies involved a random sample of 16 beluga whales. The researchers want to create a 95% confidence interval and estimate the true mean weight of male beluga whales. The data follow a normal distribution. The population standard deviation of weights of male beluga whale is theta equals 125 kilograms. And the researchers feel comfortable using the standard deviation for their confidence interval. Are the requirements for the use of confidence intervals met? Explain. Yes, the distribution of sample means is normal because the data is normal. Yes, the distribution of sample means is normal because the sample size is large. No, the distribution of sample means is not normal because the sample size is small. No, the fact that the data are normal does not imply the distribution of sample means is normal.
Okay, I found the requirements. It says there's 3. A simple random sample was drawn from the population. X is normally just distributed, and sigma is assumed to be known.
Okay, I think it's all there then.
Yeah, it says random sample. Random sample. Yeah. So, A?
Yeah.
An investigator with a stock portfolio worth several $100,000 sued his broker and brokerage firm because he felt that a lack of diversification in his portfolio led to poor performance in many years in a row. Well, in an effort to avoid close public scrutiny, the firm agreed to settle the conflict by I can't say that word, panel compared a sample of 39 months to investors' returns with the average of the Standard & Poor's 500 stock index the same period, in order to determine whether there was a substantial difference. The S&P was known return of 0.5. Suppose you are a member of this panel, conducted a hypothesis test to determine if the investor's portfolio performs significantly worse than the performance of the S&P. Wow, that's fun. Uses open the rates of return. Okay. That was retarded. We don't even need.
Read all that so you can open a file and do it on there.
Yeah. Whatever. Okay. Okay, we do a one sample t-test.
Yeah.
So it's, oh, you already know that. I was doing it wrong.
That's what I was thinking, at least. So I'm glad I did it right.
Cool. I started doing the descriptive statistics explorer, and I got me nothing.
Yeah, it's hard that we have to remember everything we've done on SPSS from the beginning now,
Right?
and then which one to use.
Yeah. So, significantly worse. So it's one-tailed, so we divide that in half.
Yeah.
So 0.247. Is that what you got?
Yeah, 0.257. Yeah. And then so 0.129 would what we put.
Okay. Yeah, that's what. Cool. Sounds not too bad.
Sweet. All right. A financial economist is studying married couples in which both spouses work. He wants to compare the mean income earned by husbands with the mean income earned by their wives. Should he use independent sampling or dependent sampling, and why? Independent sampling. The two spouses are separate people with different jobs, so the husband income doesn't depend on his wife's income. So A.
Well, he's studying the married couples, so I would think it's dependent. Because if he was studying just men and women, then he wouldn't specify
Okay.
couples.
Okay, so D. Or yeah, D.
Yeah.
Okay.
Yeah. Why do I keep getting these huge paragraphs? I'm sorry.
Okay. I'm going to save you time. The prices are given in the file direct flight costs.
Okay.
I was just like, okay, if it tells me to open a data, I'm not.
For real. I'm like the most retarded reader ever, too. What is the P?
Laugh at how big these paragraphs are for such little.
Right? We just say one. Oh, it's a two thing.
This be
What would this be? We actually have to read it down. Is there a difference in the price tickets are listed 90 days before compared with 40 days before the same flight? In her study, she compared the prices one way from London's. She recorded those. The same destination. Is that independent or dependent?
I think it's independent.
It's just because they're the same flight, like so. I actually talked about this before. I'll just find it and which lesson it is.
Okay, I think it is dependent because it's talking about the prices. So it depends on the days of the prices, right?
Yeah. We have to do the difference thing.
So how do you do the dependent ones? I can't even.
I don't know. I'm not sure yet. Hold on.
I feel like we did this problem before too, though. I just don't remember how we.
I was looking for it just, but you found it.
Is this the one where we computed the variable and did?
Yeah, where you have to compute the difference and then use that for the, yeah. I actually found the,
Okay, I think I got it then. I was starting to do it. I was like, I remember doing this. I just like had to find the right thing.
yeah.
So would you do the 90 days minus the 14 days?
Post minus, yeah. The transform compute variable.
I got 0.96 whenever you. Let's see if that one's right. Or 0.096, sorry.
It's not letting me press OK.
You have to put like a name in the top of it. Like I just put difference.
Oh.
Just to label it.
Okay. Okay. And then how do then what test?
I did the one sample t-test for it just because.
Okay.
Then just click on the difference one.
So your 0.096.
You say you got 0.096?
Yeah. Do we have to divide that? I can't. Compared. Because we're only, the question is whether they're different or not, right?
Yeah, so I think it'd just be that number, 0.096.
Cool.
All right. Based on the results of the test, can you say there's a difference in the cost of airline tickets purchased in advance compared to the 14 days in advance?
No. Because we're failing to reject the null because the p-value is higher than this.
Yeah. So C.
A real estate company wants to evaluate 2 of their home appraisers for consistency in preparation for their annual estate certificate. It is important that different appraisers be able to give similar estimates for homes of their other properties. The company selects a random sample of 10 homes in different neighborhoods around the city and independently asks each appraiser for an estimate of the home value. After they receive an estimate for each home, the company subtracts the value given by the first appraiser from the value given by the second appraiser. They create a QQ plot of the differences and see that the points of the plot roughly form a straight line are the requirements for using the desired confidence interval satisfied. I think they would be independent. So it would be good. Sample size is large. Requirements. Right, simple random sample. There's a little bit distributed. No. Sorry. I think it's just a simple random sample and the X is normally distributed. I don't know.
Yeah, I'm trying to find it too. Well, we're almost halfway done, and we've been here for an hour, so.
Yay. Okay. What requirement must be checked when conducting a market test with 2 independent samples? A simple random sample is drawn from each population, and X is normally distributed for each group. So those are definitely the requirements. Because I found that in the test and we got the answer right. So since it is a QQ plot and the lines form a straight line, that means that it's normally distributed.
Yeah. Do you think B?
Yeah, that's what I'm thinking.
I'm down with that.
Okay.
Now, suppose a company of the previous item wants to be a hypothesis to determine whether estimates given by the 2 appraisers are different. Which of the following would be the most appropriate pair of hypotheses for such test?
Okay.
Yeah, that's what.
Suppose that you create a 95% confidence interval for a mean and get those numbers. You've been told to report this by saying we are 95% confident that the true mean is in between.
I think it's A, or no, B, or no, A or B. I think it's B.
I avoid the word chance because it says in there not to use the word chance.
Yeah, so I think it's B.
Yeah.
Okay.
Yeah.
If P equals 4/5, what is the smallest value of n that satisfies the requirement for normal distribution of P hat?
What's that?
It's just finding all these formulas and everything that we had to use.
Okay. What is the smallest value n? So it's n times p is greater than or equal to 10, or n times 1 minus p is greater or equal to 10. So it's one of those. We just have to put it.
So is 4/5 P or is it N?
4/5 is p.
Okay. Like I should have just gone back and looked at the question. I knew 4/5, but it says P equals 4/5.
What?
I said I probably should have just looked back at the question. I just knew it was 4/5. Never went back to the formula. So it'd be 12.5.
Yeah, that's what I was just thinking. Yep.
Or would it would it be 50? Because it's n is greater than or equal to 50 and n is greater than or equal to 12.5. So to satisfy both those, it would have to at least be 50, right?
Oh,
Because both of those have to be satisfied, right?
right.
So,
You're right. Okay. Yeah.
so it's 50 then. Okay.
Cool. Good work.
I was like, wait, that's not right, because that would only satisfy one of those.
Exactly. Good thinking. Yeah. Okay. Your little brother has a career batting average of .233. You want to determine the probability that he will have a batting average of over 2.25 the next season when he will be up to bat 40 times. What are the conditions? Are the conditions met so that the sample size proportion P will be approximately normal? So are we doing the same once?
Would it be A? Because we're using a large enough sample.
I don't know, man. Hold on. I think it's D.
I'm down with that.
Oh, wait. It says... Oh. Yeah, I think it's... Oh.
All right. A geneticist takes a simple random sample of n equals 140 gamete sex cells from the testes of a dog to determine the proportion which contain the chromosomes for development into a male. Assume the unknown true proportion of dog gametes that contain a male chromosome is 46%. Information answer question 22. The geneticist conducts her survey and calculates p hat equals 0.512. Which of the following is the most correct interpretation of the statistics? There's a 51.2% chance that a randomly selected gamete cell will have the male chromosome. 51.2 of the egg fertilized with these gametes will produce female puppies. 51.2 of the gametes of the dog testes have male chromosomes. 51.2% of the gametes of the sample have the male chromosome.
Okay, so B hat is for the... full proportion. So...
I think it would be C.
Well, it would have to be talking about the sample proportion and not the whole population. So I'm giving it D. If it was talking about the whole population, it would just say...
Okay.
It's like the other ones, like X and mu. So P hat is X bar and...
Alright. That sounds good to me then.
Researchers published a study in which they considered the incidence among the elderly of various mental health conditions such as dementia, bipolar disorder, obsessive compulsive disorder, delirium, and alcohol. In the U.S., 45% of adults over 65 suffer from one or more of the conditions considered in this study. Calculate the probability of that fewer than 320 out of the N equals 750. Adults over 50 and 65 in the study suffer from one or more of the conditions. Give your answer in 3. Okay. So we're going back to probability. So we find the z-score?
I don't know. Maybe? Or... my first instinct was just to do 320 divided by 750, but that seems too easy.
Well, it says to calculate the probability that fewer than... That's why I'm thinking we find the z-score and then do the...
Okay.
And press less the... It's not new. Except that we don't have the standard deviation.
So for this one, would we maybe like the other one put 0.45 in the app and then do less and then put that number in? And then we have...
Huh?
No, that's not going to work either. I was talking out loud.
Okay. Oh.
This class just needs to be over.
No, come on.
But he's saving the last group meeting the longest.
Right? But hey, this is our last group meeting.
It's true.
We will again have our Tuesday and Thursday nights back. So maybe we put my only thing, I think maybe we could put 0.4. Is this what you were saying earlier?
That's what I was saying, but then there didn't seem to be enough numbers that we need in it. Like to finish the formula.
This is really annoying.
Could always make up a formula. I made up a formula and I got 0.192.
Yeah. Okay. Well.
I just hope I'm as good as guessing on this final as I was the last test.
Yeah? How'd you do on the last test?
I got a 75. And I guessed on over half of it. So I was like really expecting to see like a 50% maybe. And I was like, 75, yes.
Cool.
If we do good on the next few group assignments, like for the final project, the group project, I only need a 55 on the test to get a C in the class. So.
Have you been using the what if calculator?
Yes, I have.
This guy in my other group was like talking about it was hilarious. He's like, I use that all the time.
I'm just looking at the statistics of the class, and if he would curve the class, I wouldn't even be close to afraid right now.
Yeah. I don't think he's allowed to because there's like multiple least from what my husband tells me. There's like multiple classes and they all have to be treated equally. So I bet some of those other classes are doing better than our class.
Mm-hmm. I imagine the ones that are actually doing it on campus are doing just fine, because it's not, this stuff isn't necessarily hard, it's just teaching yourself. Like, it is hard, but at the same time, like, having someone sit there and explain it to you right there in person would be a lot easier.
Yeah. I've actually been surprised how much I don't feel like it's that. You know what I mean?
Yeah. I feel like if I would have just taken this in class, I would have, like, for me, honestly, you've been the bigger teacher than anything else, because you, like, you showed me how to do it. Like, the only reason I know how to use SPSS is because of you, because I do a lot better with people just explaining it to me rather than watching a video real quick or anything like that. Actually seeing someone work the problems that helped me a ton. So thank you. You've helped me keep the C in this class. Otherwise, I would have an F.
Well, good. I'm glad I can help, because, yeah. I don't know what to do for this problem.
Okay. So,
Do you remember this problem too, though? I feel like we've had this problem before.
not really.
No? It doesn't give us a standard deviation, right?
No. I just have a feeling we're overthinking this too much, but at the same time, I don't know what else to do.
Yeah.
Maybe.
I guess we could try just putting in, like, doing like what you were saying earlier.
The only thing I can think of is 320 divided by 70, then put that number in the normal applet, and then
Yeah.
I don't know what else we would do. And then just put shade to the left.
Did you get 0.3347?
Yeah, point. Or did you already enter it in the applet?
Yeah.
Okay.
Why not? Let's just.
What'd you say you got?
I got, well, I put 0.427 in the applet, and I got 0.3347. I shaded just to the left. Just fine.
You got 0.335, or just say. I hate when you actually look out of it. 0.3347 is what you said you got? Okay.
You got?
I got able to get to that point. Yeah. I put a different number in it, but yeah.
Oh, like a smaller.
But would you you said you only put to the left?
Yeah.
Like, so the middle. I thought it would be the middle and the left.
Well, it says what calculate the probability that fewer than that. So that's the only reason why I'm thinking that.
But if we were doing fewer 0.427, wouldn't we just shade over from 0.427? Or
Oh, yeah, I see what you mean.
because that's what I was thinking, shade over from there. because that's still.
Yeah. Oh wait, but we're putting the probability in as a z-score, and that probability isn't the same as the z-score.
That's true. So maybe put 0.427 at the top.
Yeah. I lost our spot.
Okay, so yeah. So
that guy wasn't there tonight, so I just had to email him.
so you drove all the way out there for nothing?
No, I still had a meeting with the chief, but the teacher guy.
Oh, okay, so
The chief didn't know anything about who was on or anything, so I just emailed.
Okay. Did you get negative 0.184?
Yeah, but that's a z-score, and that's not. You know what I mean?
Yeah, but I don't know what else it would be, Emily.
Either. Duh, I hate this. I don't even want to care anymore.
Can we just skip that one? Let's move on.
This
Let's go
is.
back.
I don't
I'm just going to skip that one for now, and we can go back to it.
Okay.
Because I'll probably just click yes and go on.
Yeah. We've
I'm
spent
one of those people that I can't focus for this long, and we've already been over an hour and still have, like, a lot left.
Okay. Let's just move on. Suppose you're testing in H9 equals P's, whatever, blah, 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 blah. And you're calculating the test statistic, the area to the right. Each one of the following is sorry, I don't want to read these numbers. Oh, so you just put it in and then, right? Wait. Negative. And then area to the right would be 0.0911.
Yep, that's on there.
Okay. Okay.
Sweet. Okay, suppose you are a dog breeder and you want to use a confidence interval to estimate the true mean fertility levels of a purebred Cocker Spaniel. It is known that the distribution of fertility levels of Cocker Spaniels is normal. How many measurements must you have in order to ensure the sampling distribution of X bar is normal?
30?
30? Yeah.
Okay. Sounds good to me.
Yeah.
The study is planned to compare the proportion of men who dislike anchovies with the proportion of women who dislike anchovies. The study seeks to determine the proportions of men and women who dislike anchovies are different. The sample of 41 men was taken in the P estimate, where the true proportion of men who dislike anchovies would be 0.67. The sample of women, the P hat estimate, the true proportion of dislike anchovies, blah, blah, blah. 0.84. Are the requirements satisfied to perform the hypothesis test? I don't know.
Yes, they are. Why? I don't know.
Categorical superposition. No. Wow, my baby's still sick.
I would say A because both agree.
Yeah, I can't remember what it's supposed to be. Is it confidence interval? Hypothesis test.
This is a hypothesis test.
Well, for the confidence interval, two categorical ones is that it has to at least have 5 observations in each of the two groups.
Okay. Then that's on there. That's A.
Okay. That's good to me.
Okay. Number 27. A study has conducted to measure the effectiveness of a diet program that claims to help manage weight. Subjects were randomly selected to participate before beginning the program. Each participant was given a score based on his or her fitness level. After 6 months of following the diet, each participant received another score. The study wanted to test whether there was a difference between before and after the score. What is the correct hypothesis for this analysis? I would say B. Oh wait, no, never mind. Not B. C.
Hold on, I know what the answer is.
I wish there was a way to just look at all the tests we've taken and all the questions right there. Just put it on.
Not easy. Did you say B?
I said B at first, and then I said C. But
I think it's B. Because we'd be calculating the difference.
that's what I was thinking. That's why I saw the D and
Yeah.
okay. Sweet.
Okay. Weight Watchers wanted to, what's all this weight thing? Wanted to predict how much weight a client could lose if they followed this prescribed diet exercise program in addition to their diet program. Volunteers were randomly divided into two groups. One group was dieted but didn't exercise. The other group dieted and followed the exercise program. For the exercise group, they used linear regression with percent compliance with their exercise program and the expectorant in pounds lost as whatever. And the pounds lost in 3 months as the response variable. One of the clients told them 5.5 pounds. What does this mean? I don't know.
I just can't remember what residual is.
No, that's what we just did.
I know.
Residuals. The residual of observation is defined as the difference between the observed value and the value that would have been predicted by the regression line. Something that help.
I think it's B.
Me too. Sounds good.
Okay.
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 Study in question 30. Oh, wait, sorry. Your turn.
For the study in question 30, the B1 of the regression line was 5 pounds. Interpret this statistic.
Oh, hey, I have it written down. B1 is the slope of in regression. Sorry. Oh, yeah, B1 is the slope. So,
D. There's not enough information. What do you want from us?
Yeah. Hold on. I'm so tired. I think it's C.
Sounds good.
That's all I got. Couldn't really explain why.
Basically, I figure we'll go through together right now. We'll see what answers it gives us afterwards, and I'll just go back and change them. Like, I'm probably going to take a little break. I need a break away from this computer.
Oh my gosh, but this is due tonight, isn't it?
Yeah. So I'll have to come back and do it, but...
Okay. Yeah. Okay. When creating a scatter plot, a residual plot, and a Q plot, which of the 5 assumptions among the weighted are being checked? Okay, I wrote this down.
Good job, Emily.
The linear relationship. D. The normal error term. No. Constant variance. Okay, so I know it's at least D and E, and there's one more. But normal error term. Oh, it's C.
Okay.
Because A and B are the ones you can't check.
Sweet.
Oh my gosh. Oh my gosh. There's still a lot left.
Well, we got 13 left, so that's a lot better than 43.
That's true. I can't believe my baby's so sleepy. Okay.
All right. Pressures supply and demand act directly on the prices of airline tickets. As the seats available on the plane begin to fill, airlines raise the price. If seats on a flight do not sell well, an airline may discount the tickets or even cancel flights. Ali Henrik, a BYU Idaho student, wanted to predict the price of tickets 14 days before the flight based on the price of tickets alone. For her study, she compared the price of one-way flight from London Airport to various destinations in Europe. Using Travelocity.com, she recorded the lowest published fares 90 nonstop midweek flight 9 days in advance, and then found the lowest published price from the destination 14. The prices are given in the direct flight. Notice that for some destination flights were not available. Use the information to answer questions 31 through 38. Compute the sample correlation coefficient of the prices of tickets 14 days before compared with the price of 9 days before. Give the answer accurate to 3 decimal places. Is this one where you do correlate, but 5 or 8, whatever?
I can't even think. Is this like the ones we've been doing?
I think this is what we've been doing recently.
Predict the the response and explain the independent and dependent things. Right? Sample correlation coefficient. Okay. I'm gonna get a drink of water real quick.
Sounds good. Well, let's have a 5-minute break if you're down.
Okay.
Because I've had to use the bathroom for like at least a half hour now.
Okay, cool. Yeah. Go. Well, see you in 5 minutes.
Okay.
Okay.
Love you, bye.
Sorry.
No, you're fine. You ready to push through this?
Yes. Let's do this. Okay, we already read that, right?
I'm pretty sure on this one we just do the correlate, fibrate, or whatever it's called, and then. So I got 0.780 on this one.
Oh, you already did 31?
Yeah. I don't know if I did it right, but the way I thought to do it, that's what I got.
Do you want me to do it?
Unless you trust my answer, but I think that's what it is.
I trust you.
Okay.
I mean, I can't really remember what to do, honestly. Yeah, which one did you do? The regression or the
For 31?
yeah. Yeah, that's all you right? The regression? Or correlate?
I did the correlate. I did the correlate, fibrate,
Oh, okay.
and then I just used the correlation one. Remember it gave me the correlation?
Um, I'm thinking. Maybe we have to do the regression linear with the response and the dependent and independent things. Like how it predicts this one because it says in the title that they wanted to predict the price of the 14 days before the 90 days.
So what do you think we need to do? The regression or the
Yeah, analyze regression linears and then. So I
So-
think that since they're using the 90 days, I think the explanatory. I think 90 days is the independent.
so we're using 14 as the dependent.
So I don't know which one is the correlation coefficient.
So I got 0.780 on the last one, and this one still has a 0.780 under the model summary. So I wonder if that's it. So I wonder if that's the same thing, and both tests were able to get the same point.
Oh yeah. Let's just go with that.
Okay.
I'm sorry.
No, you're fine. I just ran it through and noticed that number was there, so I'm like, that's probably it.
Yeah, that's probably it. Okay. Create a scatter plot using the two variables. Using the scatter plot and referring to the correlation coefficient above, select the answer that best describes the data illustrated by the scatter plot. Okay.
Looks like it's mostly positive.
What is yours? Can I? Does yours look like this?
Yeah, basically, yeah. I think I might have just switched what I put in the X and Y axis, but yeah, it's sloping like that with a few little ones that are out of the way.
Okay.
So that would make it positive, right? Positive
Yeah.
linear?
But ooh, sorry. Swallow the jar. Okay, sorry. But that's the one we got wrong on the homework. Or I got wrong.
I got most of it wrong on the homework. So. Or wait, no, I didn't do this homework yet. One for last week.
I mean, from the last.
That was for last week, huh? Or was that for for Tuesday?
I think it's last week's.
Okay, then I definitely got it wrong.
Should we just do that?
Yeah, I think it's B.
Okay. Let's just do that. Fill in the missing variables in the question in the linear regression line used to predict the readings, blah 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 blah. Okay. You ready for that?
So which numbers are which?
Okay, I have it written down. It's under the coefficients box.
Okay.
Under that first where it says B, it says under standardized coefficients B, that 115.64 is the y-intercept, which is BO.
Okay. And so the other one would be 0.627, so just 0.6.
Yeah.
All right. Predict. Oh, whoops. Predict the price of the. Predict the price of the tickets listed 14 days before a flight based on the same flight costing $200 90 days before a flight. Give your answer accurate to one decimal place.
Okay. So wait the
So how do you do this one again?
so
Is
we
it
just
put 200?
put 200 under the 90 days section, and then we just redo the thing, and it'll show it
Okay.
for us. So what is it? Analyze revision. Let's press OK again, and it should. And it didn't. Okay. Oh wait, you're supposed to click on something. Oh yeah. You click on. It's already clicked.
Okay. This is the one where you click on save, right?
Yeah.
And then the unstandardized.
Uh-huh.
Yeah, it came up.
You did?
Yeah, I got 240.97927.
Okay. Can I, I'm just going to go back to mine didn't work.
Okay.
Oh, I didn't scroll. It's like showed up 3 times. Okay, yeah, I got that, sorry.
Okay, so 240, should we just put 241?
Oh, yeah. Cool.
Sweet.
I'm so excited. Okay.
We're almost done. We got this.
Okay. So we use the bottom line for the 95% confidence interval. So it'd be wait, that doesn't make sense.
So we use which one?
Yeah, because it's for the slope. Okay, yeah. So it's the 0.518 and 0.735. Do you see what I'm talking about?
I do not.
No. It's in the coefficients box. Here, I'll show you. On my screen.
Sweet. Now I gotta find your screen. Where to go? Okay.
And it's his bottom one because it's 90 degrees. So he says I was confused, but then it says the interval for the slope of the regression line, so that makes sense. That would be the slope.
Sweet. All right. Choose the correct null and alternative hypothesis for this analysis. Just be A? No. Yeah.
I can't remember which B it is. Oh.
Still got one?
Yep.
You almost done?
Yep.
You're probably working hard, dude.
Don't be scared, man.
What if I get rejected?
Okay.
You go for it. Would you just go for it, or would you bring something?
Just go for it. I'm Joe Quinn, man. Let's be real.
Dude, I'm clean though. I don't think I'd be bad with it.
Oh. It's D.
D?
Yeah. I just found it in the text.
You're not paying attention.
Go away. You're distracting me.
Dude, sorry.
My roommate's here talking to me.
No worries.
Sorry, Emily.
All right. Give the value of the test statistic and p-value. Round your answers to 3 decimal places.
So 11.509. 0.
I accidentally clicked everything out, so I'm trying to get back to it.
Oh, lame.
You say 11.509?
Yeah.
Just got back.
0.000.
Yep.
Okay. Reject. No. It's C, I think.
Sounds good. All right. We're so close. We're so close.
I can do this. Oh, it's all these ones.
All right. In the United States, mothers who live in poverty generally have babies with lower birth weights than those who do not live in poverty. The mean birth weight for the babies born in the U.S. to mothers living in poverty is approximately 2,800 grams. The CDC carries out a study that tests the effectiveness of a new prenatal care program and reducing the number of low birth weight babies born. For the study, 30 mothers, all of whom live in poverty, participate in the program, and birth weight data is recorded. Which hypothesis test would be most appropriate for this study?
One simple t-test?
Z-test? Or T?
I think it's T. Because you have to have you have to know the standard deviation for the Z test.
All right.
That's my only thought.
All right. So B?
Yeah, but I'm terrible at these questions. I always get them wrong, and I have no idea why.
I always get them wrong too, so.
It's really frustrating to me because I like think it through really good, and then I get like half of them wrong.
I feel like even when I like sit there and like try to look for all of the possible things that they're there, I get them wrong still. So.
Right? Okay. Engineers in an oil refinery find out how easily gasoline evaporates by measuring its vapor pressure. As they make gasoline, they need to determine whether the vapor pressure is high enough. The standard deviation for the vapor pressure of gasoline made by the refinery is 0.03. Which hypothesis would be appropriate for this task? A, I think it's A because they give you the standard deviation.
Yeah. Okay, an attorney wants to know whether the percentage of Walmart employees in Nevada who are over 45 years old is more than 30%. Which procedure would be appropriate in this situation?
Okay, so when I'm going through these, the first question I ask is categorical or quantitative? And that's quantitative, right? Or maybe it's not.
I think it's not. I think it's categorical.
Okay, so then we tested one proportion?
That's what I was thinking.
Because, wait, so when do we use linear regression?
The one on like 43 when it says they hope to show there is a linear relationship. I'm gonna guess number 43 is I.
Okay. They hope to show there's a... That's funny. Okay. Well, at least they gave us one that was easy.
Yeah.
Okay.
Hopefully.
Yeah.
Watch us get it wrong still.
Yeah, that'd be funny. Mary Counselor conducted a study of couples, categorizing each of the couples as communicative or non-communicative. Among other things, the counselor wanted to see whether the percentage of communicative couples or whose marriage ended up in separation or divorce was the same as the percentage of non-communicative. Which hypothesis would be most appropriate for this study? Since that's categorical. I'm thinking two proportions or chi-squared.
I was thinking two proportions.
Okay. I was gonna look at the
I can't really what a chi-square test of independence is anymore, so I could be wrong.
so they're asking was the same. Okay, so they're asking, so it'd be like like the null and the alternative would be one's equal, and then the alternative is that they're not equal, right?
Yes. Yeah.
Yeah. Okay. Then I think it's G, because for the chi-squared of independence, the null is that they're independent, and the alternative is that they're not independent. So that doesn't even make sense.
Mm-hmm.
So I think it's G. Okay. We submitting?
Yeah.
I
We
don't
got
want
a 72.
What?
We got a 72.
No. Well, that's better than a D.
It is, and we got all of those last ones right.
Yes. How do we get that wrong?
How did we get that wrong? What sucks is we can retake it, but it didn't tell us the right answers.
No. Just tells you which ones are wrong.
I'm just taking the 72 and moving on with my life.
Why is that one wrong? This makes me so angry.
Whew. Well, Emily, I'll take a 72.
Yeah. Did it affect... How much does it affect? Oh, it didn't even change my grade. I don't care.
I have a 71%, so I'm imagining a 72% can only bring it up. What do you have in the class right now?
I have 82.
Dude, you got to hold on to that B. You can do it.
I'm trying.
Yeah, it didn't change my grade at all. I have the exact same.
Mine either.
We just worked on this for 2 hours, and it didn't change our grade.
I know, it's so retarded.
Oh well.
Hopefully that helps us with our final, though.
Yeah. Yeah. Except now, they'll be the same questions that we got wrong. We don't know why.
For real. Actually, but I think we should be able to view what we got wrong on after Saturday, so before the final.
Oh,
think-
yeah.
I think it usually opens up to what we got wrong by then.
I'm glad he did that this time, because usually we can't see anything.
Yeah.
Yeah. Anyways. Okay, great.
All right.
Well, I'm sorry that took forever.
No.